I would like to introduce to you Ann Micheli. Ann has been managing director at Ultrafox since 2012. Her background is assisting small and medium-sized firms to diversify and to internationalize. Brought her into the fire suppression industry some 15 years ago, where she has been enjoying the challenge of developing a small Italian marine fire company into the international group that it is today. And Ann will talk about a hospital project in Sweden. So this is a case study, and the stage is yours.
Thank you very much, Bettina. Good morning, everybody, and thank you very much, particularly to the IWMA, for the opportunity to speak and present this project to you today. The project that I'm going to present to you is a hospital project, but healthcare facilities come in all shapes and sizes. Buildings can be new builds, old builds which need retrofitting with a fire system. They can be small and they can be very large. For the purposes of this project and for this presentation, I'll just go over some of the varying spaces which you can find inside modern hospitals. Modern healthcare facilities resemble mini cities almost, with many varying spaces and many different fire risks. And the analysis of those fire risks is the essential starting point to any fire suppression installation project. Examples of those different spaces can be patient wards, operating theatres, atriums, which can have very open spaces and high ceilings, entrance halls, kitchens, restaurants, shops, underground, parking facilities, technical spaces, including the laboratories that Lucas was describing in his presentation. And modern hospitals increasingly have a whole backstage behind what you see when you go into a hospital. And those are the automated background service systems. So they can be laundry systems, which can be laundry carts that will automatically follow coloured lines into the different wards to be filled with laundry, and then they will go back behind the building and down, usually into underground spaces where the laundry is cleaned. The other typical automated system is automatic pharmaceutical picking and delivery facilities. So they can often, particularly for the small packages, a little bit like Amazon warehouses, they will run up through the ceilings. So when we install or we start to design a project for a hospital, we have to take into account all of the different routes and all of the different fire risks that are coming together in a single building or a set of buildings. One of the things, however, that is common to all of these spaces is, of course, people. In a hospital, you're going to have patients or residents with very limited ability to respond to any alarms, perhaps not even be able to walk on their own. Staff and other workers, rarely in the numbers sufficient to achieve a full evacuation in the event of a fire. Visitors who will also often have no knowledge of the building layout and of the escape routes in the case of a fire. So a full evacuation in a fire event would have to rely on the arrival of the fire and rescue services, and that, as you know, can take some time. One of the most effective ways to safeguard these vulnerable people is to install an automatic fixed fire suppression system, and water mist systems are particularly suitable in these types of environment. So why water mist? I mean, Bettina's gone into the way that water mist functions in quite a lot of detail, so I'll just skim over this. But suffice it to say that water has unique properties when it comes to firefighting. It absorbs a relatively large amount of heat to raise the temperature, and once it reaches 100 degrees C, it then converts to steam, and in so doing, it absorbs a further amount of steam and temperature. In converting to steam, it expands to 1,620 times its volume. And these characteristics of water in a fire situation are best exploited if it can be delivered in small droplets with sufficient momentum to penetrate the fire plume. An automatic sprinkler, for example, will produce droplets of about 1 millimeter diameter or more in a litre of water. That will have a surface area of 2 square meters. In contrast, a water mist nozzle delivering 100 micron size droplets will produce a surface area of 200 square meters from 1 litre of water. So as we can see, that will significantly improve the ability of the system to control and suppress a fire. In the right-hand graph that you can see on the slide here, you can see how pressure has an effect on that delivery of the water. So you can see the vertical line is water density, and the horizontal line is pressure in bar. And you can see how the increased pressure after over 50 bars, you get to a very significant cooling effect. I'll just move on now to my case study, which is a Swedish one. This is a project that we started in 2015 at the Sahlgrenska Hospital in Gothenburg. This hospital, just to spend a couple of words on it, it's a world-renowned university hospital, and a few years ago they decided to build a dedicated eye clinic and associated intensive care unit. This is now a centre of excellence, and it's particularly specialised in paediatric ophthalmology, excuse me, and that means that we also have sick and often blind children in the building, which will be an added risk when it comes to evacuation in a fire event. So the clinic comprises of 2 separate buildings connected by a series of external walkways between the 2 buildings, and from these buildings to other buildings in the hospital complex. They're low-rise buildings, so each building is about 10,000 square meters, divided up into various rooms and spaces, and there are 7 floors above ground. The project was designed to be a 2-phase project. The first phase was the first building, and that comprises the eye clinic. And then the second phase was the second building that you can see on the left, and that's the intensive care facility. And there was also a whole host of administration and reception areas. The design criteria for the building was primarily OH1 fire risk, and it was also specified that we should respond to EN 12845, which is the European Automatic Fire Sprinkler Standard. So it's not a standard that is specifically designed for water mist, and so we had to find some novel solutions in order to be able to respond to that. This kind of situation is now going to be resolved because we have a specific European water mist standard which is coming out this year, a little bit later this year, and that's EN 14972. I think that the IWMA will probably be one of the first people to publish that on its website when it's ready. So what were the reasons that the customer, who is the municipality of Gothenburg, what were their reasons for specifying water mist? Primarily, the problem was that the client was up against problems with water supply. This is a very common problem across municipalities in particularly Sweden and Scandinavia, funnily enough. And the normal way to solve this problem is to install a large water tank. But in this case, there wasn't the space available at the Sahlgrenska building to be able to do that. The second reason would be that there would be a lot of very costly and sensitive equipment that they didn't really want to risk damaging with huge amounts of water or other types of damage which could follow in a fire event. There was also a very tight building schedule, and the small dimensions of the pipes used by the water mist system, so 12mm mainly as you're coming into the nozzles, was a very important decision maker and something that was a winner for us. The other thing was a lifetime cost analysis, which is increasingly part of the bidding requirements for these types of projects, showed that the water mist system came out in a very favourable light in terms of cost of maintenance over a 10-year period. So this system, just to go a little bit over what it looks like, the client wanted to have 100% system redundancy. This was in consideration of the high value equipment that was available, but also the patients inside, which should a system fail, it would be great to have a backup so they would be sure that evacuation could be completed. This was achieved by installing two separate systems. Each system primarily serves one of the buildings, one of the two buildings, but the system is also connected to the other building as a backup. In this case, pH 80 pumps were used, and each pump is capable of delivering 220 litres per minute. The system that is installed in this case is working at 100 bar, so it's a high pressure water mist system. And I'll just go down to the next one. This is what it looks like in terms of its design. So what we have down here at the bottom, if you can see, is the main equipment, which is all installed into a single technical space. So we have the two pump units, we have two control cabinets, and then from there the section valves piping up to the various floors, and which you can see up above that. So the system is designed to protect what we call the most demanding area. In this case, the most demanding area was identified on level 2 in the building. It's an area comprised of 72 square meters. And in this, we have the ability to activate 6 nozzles simultaneously, each nozzle requiring some 36 litres per minute. This is just a pretty colourful slide, but in this project we were also required to produce 3D piping drawings. And so this is just an illustration of some of the areas and what they look like in the drawing. In water mist systems, the nozzles that are used are tested for each type of application. So we tend to use in a single system, we will use different types of nozzles. In this project, we can see that we have one type of nozzle here, which is approved for 2.5 meters height, 5.3 meters spacing between the nozzles, although there's no coverage limit. This particular nozzle can protect up to 48 square meters. The implication of that is that you can install less nozzles because they're protecting a greater area, and that will of course bring down your installation costs. Then we have a second nozzle type, which is approved for 12-meter heights. Those will typically be used in the reception areas and entrance halls, which have quite large high ceilings and open spaces. 4.5 meter spacing, no coverage limit. And then a standard automatic bulb, 2.5 meter height and coverage of 12.25 meters. And they will be used in smaller areas like the bathrooms. Now, this isn't a photograph or photographs from the actual hospital project, but I just thought it would be a useful slide to put in because it shows just how small those 12 millimeter pipes are when they come up to the nozzle. And we can see on the left-hand side there also a sidewall nozzle, and you can see the bending pipe coming from behind the wall into the protected area. So I'll just, it's just for illustration purposes. To sum up my presentation, water mist is a tried and tested technology, and I wanted to put that down first because one of the most common criticisms that we face in the marketplace is the idea that water mist in some respect has not been tried or tested or is not approved, and that's very much not the case. And increasingly, water mist systems are specifically governed by recognized international standards. So in the land systems particularly, we now have this water mist European standard coming out, the EN 14972, and I think this is a very, very welcome move for all of the water mist market because it will show that there is a unified standard against which we can design and measure our systems. Water mist systems, as we've seen, are both in my presentation, but particularly also in Lucas's presentation, that we offer flexible, personalized solutions, and that's a very important point because each nozzle, each space is different, and it's very important that we should be able to show that every space where we go and protect has a nozzle that has been tested to that fire risk. So the water mist systems are fit for purpose. Then there's the common takeaway, which is there's a very high fire suppression efficacy with less water when compared with traditional sprinkler systems. Ease of installation, and that's particularly important in a healthcare environment. Quite often we're going into buildings which are running 24/7. If you think about an elderly care centre, it's very inconvenient and very difficult to move old people out of their rooms or out of their buildings for even a short period of time, and it causes quite a lot of psychological disruption. In this case, you can, and we frequently do this, you can install the system with relatively little disturbance and disruption to the ongoing operations of the healthcare facility. Easy to retrofit, small piping, as Lucas also has highlighted. This is a perfect system for going into older buildings and working around the structures that we find. Most manufacturers of water mist systems will also be offering lifetime service and maintenance provision, and that, of course, is another reassurance in terms of installing a water mist system. So I'll finish there, and thank you very much for your attention this morning. And again, my thanks to IWMA and Bettina particularly for organising this session.
Thank you very much.